Good morning, students. In the today's session, we'll learn about Internet Protocol. Okay, this will be for the transmission of data between the sender and receiver. Okay, the protocol means which is going to use some rules for the transmission of data. Here we are in the today's session, we'll learn about what is ARP as well as RARP and also BOOTP as well as DHCP. Okay, these are the four protocols which we'll learn in the today's session. Okay, now here first, we'll start with what is address resolution protocol. Okay, let me see here. Whenever if we are mapping the logical address to physical address, then it is called as a address resolution protocol will be helpful. Okay, that means one of the very important, the most important protocol in the network layer is the address resolution protocol. Okay, and here the ARP, it is going to find the physical address. It is also called as a MAC address. Okay, this will be normally whenever if you are working into your lab also, whenever if you want to connect from the client to the server, there also you are going to use some MAC address you are going to use. That is only the IP address. Okay, and here this ARP mapping means here the logical address will be converted into the physical address, that it is called as a ARP mapping. Okay, the logical address which is converted to the physical address is called as a ARP. Here in this, what is happening? See, for example, let us take the normal generalized example. Here in our lab, we have a number of client systems. Okay, all these clients are connected to server. Okay, all these clients are connected to server. How these clients are going to connect to the server? By using some MAC address. Okay, here this is the MAC address. Here this is the MAC address. That means here the system A is connected to the system B. Okay, and it is going to request for some data. Now this system B is, we can call it as a server or the other system. Okay, and by using the proper MAC address, it is going to send reply to the client. Okay, this is the process which will be happens for the ARP operation. Okay, and now here for the ARP operation, what are the steps which we are going to follow? Okay, the first step is the host or the router sends an ARP query packet. The host or the router sends an ARP query packet. The ARP query packet includes the physical address as well as the IP address of the sender. Just see here, this ARP consisting of the physical address as well as IP address of the client. Okay, and that means based on its requirement. Now here the ARP query packet, it includes the physical as well as IP address, and the sender does not know the physical address of the receiver. The ARP query is broadcast over the network. Okay, and it is based on the ARP address, it is going to send back the data properly. Okay, and what is happening at the other side? Every host or router on the network receives the process. Okay, receives and processes the ARP query packet, and but only the intended recipient recognizes its IP address. Okay, and then this by using the ARP, the server is going to send back the response packet to the client. Okay, and in the next step, what happens? The ARP response packet contains the recipient IP as well as the physical address. Okay, and the ARP response packet is unicast directly to the input. Okay, by using the physical address received by the query packet. Okay, and now see here, what will be the format for this ARP packet? Here, whenever you are working with this ARP format, okay, now the first basically is it consisting of, like the normal, it is only the 4 bits. Okay, 4 division partition will be there. Okay, now here it is having the first as 8 bits, then we have 8 bits, then remaining 16 bits. Okay, and it is going to use the hardware type, then it is going to give the protocol type. That means most of the system, the last 2 numbers will change, not all the numbers. Okay, and it is going to have the hardware length as well as the protocol length. Then we have the operation. The operation may be either request or reply. Okay, now here the sender is going to have the hardware address, and the sender protocol is having the address also, and the target hardware system. Okay, and next here the protocol address also. That means this is the complete format for the ARP packet. Okay, this is the complete format for the ARP packet. Okay, now here the fields, what are the fields which we have? That means here we have 8 bits, 16 bit, 8 bits is the protocol type. Okay, like here, what are those, all those things? Now here the first thing which we have to understand is, First one is the hardware type. What is this hardware type? This is a 16-bit field. It defines a type of network on which the ARP is run. Okay. Defines the type of network on which the ARP is running. And each LAN has been assigned to an integer based on its type. Okay. For example, Ethernet is given type 1 and the ARP can be used on the physical network. And the next one is what is meant by this protocol type. Here, this is a 16-bit field defining the protocol. For example, the value of this field for the IPv4 protocol is 080016. Okay. And the ARP can be used with any higher level protocol. Okay. And the next one is what is meant by this hardware length. Here, this is an 8-bit field, defines the length of the physical address in bytes. For example, the Ethernet value is 6. Okay. And next here, now we have the protocol length is also there. This protocol length means it is an 8-bit field defining the length of the logical address in bytes. Okay. For example, IPv4 protocol is the value is 4. Okay. And the operation what we have here, we have the two operations. One is the ARP request, another one is the ARP reply. Okay. That means the operation means it is a 16-bit field defining the type of packet. Okay. That means there are two types of packets. One is the ARP request, another one is the ARP reply. Okay. And now we have the sender hardware address. Okay. And this is a variable length defining the physical address of the sender. For example, Ethernet in this field is 16 bits length. Okay. And sender protocol address, target hardware address. What is meant by this sender protocol address? This is a variable length field. Okay. Defining the logical IP address. Okay. For the IP protocol, the field is 4 bytes long. Okay. And the target hardware address means this is a variable length field defining the physical address of the target. Okay. For example, Ethernet in this field is 6 bytes long. Okay. And the message, this field is all zeros because the sender does not know the physical address of the target. Okay. And now here we have a number of examples. Here I have given with one sample example. In this example, what I am showing is here in this example, I have a IP address called 130.23.130.23.43.20. And the physical address for the B2 is here. This is the physical address. Okay. And 10 packet has to send to another host with IP address. Okay. That means here we have the IP address for the sender is 130.23.43.20 and the receiver IP address is 130.23.43.25. Okay. And the physical address is, this is the physical address. The two hosts are on the same Ethernet network. Show the ARP request and reply packets encapsulated in Ethernet frames. Here, what I have given, here I have the ARP request. How the ARP is giving the request here, normally it is 32 bits. Okay. This 32 bits is divided into 8, 8, and then 16. Okay. One is the protocol address, one is the hardware address, another one is the receiver address. Okay. Sender address. Okay. Here, like this, it is going to send the request. And after processing the data here, if it is all zeros, means the receiver does not know the sender address because the receiver does not know first. Okay, once the processing has been completed. Okay, here sender protocol address. Okay, the variable length defining. Now sender hardware address. This is a variable length defining the physical address of the sender. Okay, and here message, this field is all zeros. Okay, because the sender does not know the physical address of the target. Okay. Because here the target hardware address we should give, but the physical address, the sender does not know the target hardware address. Okay. Then after processing because the complete task is going to be handled by the ARP, and after processing the data, it is going to send reply back to the client. Okay. Here, this is the sender system, and we can call it as a receiver or target system. Okay. Next here. Now we have done with only ARP. Now we'll see about what is meant by RARP, Reverse Address Resolution Protocol. Okay, here mapping physical to logical. Here in the last what we have done here, logical address to physical address is known as a ARP. Now what we are doing, we are diverting the physical address to the logical address. Okay, previously what we have done, we have converted the logical address to physical address is called as a ARP. And the conversion of physical address to the logical address is known as the RARP. It finds the logical address for a machine that knows its physical address. Okay. To create an IP datagram, a host or a router needs to know its own IP address or addresses. Okay. The IP address of a machine is usually read from its configuration file stored in a disk file. However, diskless machine is also used, which is booted from the ROM. Okay. And here the ROM is installed in your manufacturer, installed by the manufacturer. Okay. And it cannot include the IP address. Okay. The ROM cannot include the IP address. Okay. On a network or assigned by the network administrator. Now here in this, the main operation for the RARP protocol is here in ARP, we have the conversion of physical to logical to physical. But in RARP, it is in the reverse order. Okay, that is physical to logical. Okay, and here this RARP request is created and broadcast to the local network. And another machine on the network, local network, knows all the IPs. Okay. And RARP request is created and broadcast to the local network. And another machine on the local network that knows all the IP addresses. Okay, it will reply with the RARP reply. And the requesting machine must be running on a RARP client. Okay, and the programming here, the responding client. Okay, otherwise we can also call it as a responding machine, must be running on a RARP server program. Okay, now this is the process. Here we are going to give the physical address, and it is going to use the IP address to give reply back to the client. Okay, and here this RARP, here this is a reverse address resolution protocol, because here we are in the ARP, the target system address no one knows. Okay, but here in a reverse address resolution protocol, we know the target system IP address. Okay, now here what is meant by bootstrap protocol? Here, this is a client-server based protocol at application layer, which is designed to provide the physical address to the logical address mapping. Okay, and the administrator may put the client and the server on the same system. Okay, and here in the following figures, I am going to explain you about the physical and logic. Okay, now here we have the bootstrap data encapsulation. In this, what is happening? Here, the client is going to send the packets one after the other. That means the data is going to be transmitted in the form of packets. Okay. And in this bootstrap protocol also, here we have the IP header and with the datagram. Okay. That means for each and every protocol, for each and every packet, because the data is transmitted in the form of the packets. Okay. We can also call it as a datagrams. Okay. Now, here, in this, how the bootstrap protocol is going to work. At the beginning, each network participant does not have any IP address. Okay, because the network administrator provides the host on the network with a unique IP address. Now, for our client system also, if you connect to the network only, then only we'll get some IP address. Otherwise, we'll not get any IP address. Okay, and the client install the bootstrap protocol network using the TCP/IP intervention on its computer system to ensure the compatibility with all network protocols when connected to this network. Okay. And here, the uses of this bootstrap protocol are here. We'll discuss the uses. The first one is what it is primarily required to check the system on a network. The first time you start with your computer and records the BIOS cycle of each computer on the network to allow the computer's motherboard and network manager to efficiently organize the data. Okay. Transfer on the computer as soon as it's bootstrapped with the network which is required. Okay. And this is mainly used in a diskless environment and requires no media as all data is stored in the network cloud for efficient use. Okay. And this bootstrap protocol is the transfer of a data between the client and a server. Okay. To send and receive the request and corresponding response by the networking server. Okay. And this bootstrap protocol, it supports the use of motherboard and network manager. So no external storage outside the cloud. Okay. Now here, the other advantage is this Bootstrap protocol network administrator sends a message that contains a valid unicast address, and this unicast address is then forwarded to the Bootstrap client by master server. Okay, and here, same as this Bootstrap, we have this DHCP operation. What is meant by this DHCP? Here, it is going to provide you an automated way to distribute as well as for the updation of IP address. Okay, always our main work is what? For the transmission of data between the client and server. And this DHCP means it is a protocol. Here, it is going to send a discover. Then here, first, it is going to ask. Then it is going to give a reply. Okay, and it is get the request. Okay, and here finally we'll get the acknowledgement from the server. Okay, and here what are the other main 4-step process for the DHCP client is here. This DHCP client sends a broadcast packet, okay, to discover the DHCP service on the LAN segment. And the next one is here in the next second line. Here the first it is going to give the request, and it is going to get the offer. From there it is going to send the request. Okay, and finally the DHCP client will get the reply back from the server. Okay, all the best. We see you in the next session.